Hi again, guys. Working on Geometric Optics Thin Lens Formula Fun Sheet 2. We're working on number 1. So we have a 24 centimeter tall object, 50 centimeters in front of a thin lens with a focal length of positive 15. Doggo is still napping. We're doing this all on the same day. So I decided to do it a little smaller. I think it's going to work a little bit better if I write smaller. So we know that the focal length is plus 15, means that it is through the lens over on the right side, because our right side is positive and the left side is negative. Knowing that our focal length is a positive distance means that we also know that our lens, in this case, is a plus lens. Upward arrows are plus lens, or I say upwards. In this case, if you look at the top half, up is plus, down is negative, and then inverse down here, it's just complementary. But if you need help remembering, up for plus, down for less, for negative, for a minus lens. Or fat. Oh, that's a good way to do it too. Fat lens, which is the plus lens. And then if it was a minus lens, face it, center in the center. That was a terrible thing. Pretend I didn't do that. So focal length is plus 15 centimeters. So we're here on the right. I know that we've got a 24 centimeter tall object. I'm just going to put the object size as 24 centimeters. And that the distance for this is minus 40 centimeters. I believe it's minus 40. Okay, so why am I writing this off to the side here for at this moment? Because if positive f here is plus 15, positive 2f is going to be 30. So this is going to be minus f is minus 15. This is minus 30, which means that if our object is minus 40 centimeters away, it's going to be somewhere out here. It is minus 40 centimeters. I don't usually work with this, but I'm going to leave it in this one for you guys. For mathematical purposes, I should have been more consistent with the last ones too. Object is 24 centimeters. That does not look like a 4, it looks like a 9. It's because I'm a terrible writer. And okay, so we're going to find V, M, and I, as we normally have been. V is the image distance. So V is image distance minus negative 1 over U plus 1 over image distance equals 1 over the focal length. We know that U is a negative 40. We don't know what V is, but we know that the F is positive, so it's 1 over 15. Because of the negatives, those become a positive. We subtract 1/40th from both sides, so it becomes 1 over V equals 1/15 minus 1/40th. Handy dandy calculator, what have I done with you? Look at the expo point. Stoop. 1 divided by 15 minus 1 divided by 40 equals about 0.0417. So 1 over V is about equal to 0.0417. Here, because we can just throw this over a 1, we can cross multiply. So we've got 0.0417 V equals 1. So V equals 1 divided by 0.0417. So V is about equal to 1 divided by E. Answer. It's going to be about 24. And that's going to be because since I did it with an answer, it's going to give me exactly 24. If you do it with that rounded, it's probably going to give you a 24, a little over 24, a little under 24. So let's just look. So let's go, if we did it at what we rounded it. 417. A little bit under, see? So this is what the difference can make. We got an exact answer here. We got a roundable answer here, which gets us close to this exact answer. Anyway, continuing. So we know that the image distance is about 24 centimeters. So B equals 24 centimeters. We're going to look for magnification next. So you can hang out while I erase the board. Oh, I really hope that I haven't made anybody throw up with these. I'm sorry. Again, maybe if I have to, if we do more stuff like this, and I can make this, I can actually get my mom to like stand there and do it or something. She's got the baby with her right now, so we're not gonna worry about that at the moment. So magnification formula is M equals V over U, which is also equal to I over O. So we know that V is 24 centimeters. U is minus 40 centimeters. Which means that this is the image is going to be on the right side. We also know we're going to be looking for I here in a second, which is image size, and we know that the object size is 24 centimeters. So this is just getting us primed for the next one. So 24 divided by negative 40. 24 divided by negative 40 is negative 0.6. So magnification is technically 0.6. The reason I'm going to put negative here is because of what comes next. So we know magnification is going to be negative 0.6 here. Image over object. If we cross multiply, this is going to be over a 1. So negative 0.6 by 24 is equal to I. Negative point, thank you. Second answer by 24. So I've got a negative 14.4. I is equal to negative 14.4. So I is 14.4 centimeters inverted. Means that the image is going to be somewhere around here. It's going to be before the focal length because of the 14.4. No, it's not. No, it's 24. Sorry. Wrong. Size is that. Image distance is 24 centimeters. If the first focal length is 15 and the second is 30, image is going to fall somewhere here. It's going to be somewhere in here. And that it's going to be upside down. It's going to be inverted. And that means that it's also going to be 14.4 centimeters tall. So when the light goes across the top here, hits the lens, it's a plus lens, so it's converging light. It's going to converge light, and it's going to go through that first focal length and down. The second one is going to go through the, oh shit, pretend I did that through the optical center. And through, and where they meet over here is where the image is going to focus. So pretend that this was up through here. I'm trying to make these a little bit faster. They're still not super fast, but this is number 1, fun sheet 2. It is a real inverted image. I just breathed all over that. I have no idea if you'll hear that. It's a real inverted image with a plus lens. And there's all your information for the image distance, magnification, and image size. So if you have any questions, fun sheet 2, number 1, put it below.